In the name of God, hello dear students, my name is Masood, I'm a physics teacher. I'm at your service to explain physics curriculum grade 11 for you. We have an application by the name of Verhwas. Also, we have a website. By this name, you can follow our videos. Let's say our goal is to explain the physics, to make the physics and make the curriculum easy for you as much as possible. Uh, in previous lesson, I explained the displacement and distance. We compared between the distance and displacement. Unfortunately, sometimes distance and displacement are used interchangeably, and it's not scientific. It's not physics does not accept this. I want you to be accurate in order to detect the distance from displacement. Uh, let me let's say recap the previous lesson quickly for you. Distance has no direction. Distance is not directional quantity, but displacement is a physical directional quantity. Displacement requires direction, but distance not, right? And displacement must be a straight line, but distance might not be a straight line. Distance may not be a straight line. Sometimes a straight line, sometimes not. This, let's say, brief of your summary of the last lesson. Um, and last lesson we mentioned three properties of displacement. Displacement has three properties. The first one, displacement, and I discussed it with you, is the difference between the final coordinate and initial coordinate. I explained it for you, I discussed it with you, and I wrote a rule, let's say, regarding this property. Right now, we are going to discuss the second property. Uh, Let me read the property for you. The second property, let's say, has to do with displacement. Displacement is not always equal to the distance traveled. Displacement is not always equal to the distance traveled. What does it mean? It says it's not always equal to this distance traveled. Means sometimes displacement is equal to the distance. Based on this reading and based on this expression, exactly, displacement is not always equal to the distance traveled. Means sometimes distance is equal to distance is equal to displacement, sometimes not. So this we want to discuss this one by an example. Actually, there's an example. A gecko, let's say, runs up a tree trunk. You have to put a convenient, let's say, frame of reference in order to designate the position, initial and final position of the gecko. And a convenient tool for this purpose is a meter stick placed vertically along with the motion of the gecko, I mean vertically. And here, instead of delta x, we denote the displacement or and distance by delta y. We denote it as delta y because the motion is taking place vertically, not horizontally. If the motion happens horizontally, we can denote the distance and displacement as delta x. But here, this situation is different. The object, let's say, the reptile moves vertically. That's why you have to use the convenient coordinate rule. So this is yi first coordinate. It points to the 20 centimeter mark, yi, right? The initial position. And yf, points toward the 80 centimeter mark. So the gecko moves from 20 centimeters to 80 centimeters without retreat. This is the first case actually. There are two cases for explaining this property. For explain this, there are two cases. The first case without retreat, without coming back, without return. Just the object, the moving object, just changes its position from initial position to the final position, and that's it. This is the first case. So the first case is called without retreat, without return, without coming back. The object moves only, let's say, the object follows a one-way track, right? One-way track. So separately, we wanna convert the separately we wanna calculate the displacement and the distance. So the result of the first case without retreat, we wanna let's say focus on displacement firstly. For the displacement, delta y is equal to yf minus yi, final coordinate 80 centimeter, minus initial coordinate 20 centimeters. So 80 minus 20 becomes 60 centimeter upward. You see, we mentioned the direction of displacement, 60 centimeter upward. Without direction, your answer is not accurate. Right. About the distance. Distance traveled, delta y is equal to yf minus yi. The same rule. We use the same rule. And delta y is equal yf means 80 centimeter minus initial coordinate 20. 80 minus 20 becomes 60 centimeter. I want you to be accurate. I want you to take a look at these answers. Do you observe any, let's say, do you observe any difference between the displacement and distance or not? If you are accurate, you can observe that the displacement, let's say, has a direction, but distance not. That's why I can say numerically, without retreat, if you have without retreat, only one-way trip, right? In the case of one-way trip, without retreat, without return, distance is equal to displacement, right? Without retreat, displacement is equal to distance traveled. This is the first case. Maybe you say, teacher, what do you say? What do you say about the case that the gecko comes back to its original position? I'm going to discuss it with you in the second case. So second case is called with retreat. With retreat, right? We want to discuss the second case. The second case is called with retreat. So we have a two-way trip here. Two-way trip. The object moves from initial position to the final position, and after that, it comes back. It comes back to its original position. It comes back to the position where the motion was started. Right. So second here, with retreat. Right now, the gecko moves horizontally. You have to, let's say, put the convenient frame of reference for the motion of the gecko, and the convenient tool for this purpose is the meter stick placed horizontally under the feet of the gecko. The gecko starts its trip from 24 centimeter mark. So this is called initial coordinate or xi. You see, in the previous case we didn't use x. We used actually we used y, yi, and yf, and delta y. But here we must use xi, xf, delta x for distance and displacement, because the motion is taking place along the x-axis, right? X-axis. So the gecko moves from 24 centimeter to the 84 centimeter mark, right? And after that, it comes back. This is the first way. And after that, the gecko comes back on the same, let's say, comes back on the opposite direction, and it returns to its original position. This case is called with retreat. Yeah? With retreat, with return. The object returns back to the original position. So what's the result of this case? Displacement is equal to zero. This is strange, yeah? Maybe you say, teacher, how is it possible the object moves from 24 centimeter to 84 and it comes back to its original position? So it actually it travels the distance twice. How do you say the displacement is equal to zero? Because it comes back to its original position. This is called with retreat. So keep in mind that with retreat, displacement is equal to zero. There is no displacement with retreat, right? When the object moves to its original position, displacement becomes zero. This is the first result. The second result, let's say, is about the distance. Distance becomes twice. So distance becomes twice. From 24 centimeter moves to the 84 centimeter and it comes back to its original position. That's why we have a two-way trip. We have a two-way trip. You have to measure the distance, let's say from 24 to 84, and from 84 to 24. That's why distance becomes twice, but this displacement becomes zero. I'm gonna solve it mathematically for you for better understanding about the displacement. Delta x is equal to xf minus xi. Delta x means displacement, right? Xf means final coordinate or final position, minus xi means initial uh, coordinate or initial position, right? Delta x is equal to xf minus 24 minus 24. Maybe you say, teacher, in the figure xf points toward the 84 centimeter. Why did you use 24 minus 24? Because in the case of retreat, keep in mind that in the case of retreat, initial position and final position would, let's say, will be the same for what? For displacement. For displacement, in the case of retreat, initial coordinate and final coordinate is the same. So xi is 24, right? It becomes xf as well. That's why it will be 24 minus 24 is equal to 0. Delta x is equal to 0. So displacement is equal to 0. It, let's say, it's corresponded to the first result. Our answers corresponded to the first result. Let's move on to the second one about the distance. Right. Distance, delta x is equal to 2 multiplied by a bracket xf minus x. Keep in mind that delta x is used for distance and displacement. The symbol is common, right? But here is used for distance. Delta x is 2 multiplied by xf minus xi. Teacher, what's this number? Why did you put 2 in front of the bracket? This number means the object returns back to its original position, right? It means distance becomes twice. You can use another way actually for finding the distance. You can measure the distance, let's say twice. You can add the, let's say, add two distances together. Like what? Like this. Xf, let me write it for x. You can say xf minus xi. Right. This is the first bracket, first path. Right. The object moves from left to right, and after that it moves from right to left plus xf minus xi. So you can use the rule of displacement. Excuse me. You can use the rule of distance twice. But here I think it's let's say it's better way than the other. Both of ways, actually, both approaches are convenient, but this one is a little bit shorter, right? So delta x is equal to 2 multiplied by xf. So xf. Just focus on the first track. First track. What's the first track? From xi to xf, right? Measure the distance once, and after that multiply by 2. That's why xf becomes 84 minus xi becomes 24 multiplied by 2. So the answer, let's say inside the bracket, will be 60. Subtract 24 from 84 will be 60. So 2 times 60 becomes 120 centimeters. That's why the distance becomes twice. The distance for one-way trip is 60 centimeters. But when the object returns to its original position, that's why it travels 60 centimeters as well. That's why 60 plus 60 becomes 120. You can substitute this if you are not satisfied with this number, with this coefficient of 2. You can measure the distance twice, no problem, like this. 84 minus 24, the first bracket, plus 84 minus 24. That's it. So 60 plus 60 becomes 120. Yeah, we get the same result. 60 plus 60 is equal to 120 centimeters. And that's why, in order to actually, I want you to measure the distance once, and after that multiply it by 2. That's all, guys, for today. Thank you very much for watching this video, and bye for now.